In schools, NCRT reading often doesn't receive the emphasis it deserves. Teachers conduct lessons, students take quick notes, and that's usually the extent of it. However, the NCRT textbooks are crucial for CBSE as well as for any competitive exams. This is particularly true for chemistry, where mastering every detail in the NCRT textbook is more than sufficient. Trust me, it's the essential foundation. Establishing a strong grasp of the fundamentals through NCRT is vital before turning to guidebooks, which should be used merely for reference. Reading NCRT thoroughly is an absolute necessity. If you're looking for a guide to help you navigate and understand the NCRT textbooks, you have come to the right place. I'm your scholar from Scholar Quest, here to assist you through the entire process. In this video, I'll provide line-by-line explanations of NCRT chapters. So sit back, relax, grab your textbook and headset, and get ready to dive into the engaging journey of learning with me. Right, getting into the first video of the series NCRT line by line explanation, let us get into the very first lesson of chemistry part 1, which is the solutions. Here, I would be reading every single line from the NCRT line by line, and then I'll go about with the meanings or the explanation of those points given in the text, and also provide you with the important points that are to be noted that you might miss when you are reading. So let's get started. In normal life, we rarely come across pure substances. Most of these are mixtures containing two or more pure substances. The utility or importance in life depends on their composition. For example, the properties of brass, mixture of copper and zinc, are quite different from those of German silver, which is a mixture of copper, zinc, and nickel, or bronze, which is a mixture of copper and tin. 1 part per million of fluoride ions in water prevents tooth decay, while 1.5 ppm causes the tooth to become mottled, and high concentrations of the fluoride ions can be poisonous. For example, sodium fluoride is used in rat poisoning. Intravenous injections are always dissolved in water containing salts at particular ionic concentrations that match with blood plasma concentration, and so on. In this unit, we will consider mostly liquid solutions and their formation. This will be followed by studying the properties of the solutions like vapor pressure and colligative properties. We will still begin with the types of solutions and then various alternatives in which concentrations of solute can be expressed in liquid solutions. This was the introduction. So, getting into the explanation, the paragraph discusses how pure substances are rarely encountered in daily life as most materials are mixtures. The importance and utility of these mixtures depend on their composition. Examples include brass, German silver, and bronze, which have different properties due to their varying metal components. It also highlights how small concentration of ions in water can have significant effects, such as fluoride preventing tooth decay or fluoride being toxic itself. The text then introduces the study of liquid solutions, their properties, and methods for expressing solute concentrations. So we'll go step by step into the into the text actually. We'll start about with the types of solutions, then go about with different kinds of different alternatives of concentration terms that can be used to express the concentration of solutes in liquid, and then we'll go about with vapor pressure and some other properties like colligative properties. So these are all the mixtures that I've found from the web that I've given as a picture for your reference. And yeah, very importantly, there could be one markers from the introduction para, like as in what is brass or bronze made of, and so never miss out reading the intro of any lesson. Just give it a quick glance, right? Then, getting into the first topic of the lesson, types of solutions. Solutions are homogeneous mixtures of two or more than two components. By homogeneous mixtures, we mean that its composition and properties are uniform throughout the mixture. Generally, the component that is present in the largest quantity is known as solvent. Solvent determines the physical state in which solution exists. One or more components present in the solution other than solvent are called solutes. So in this unit, we shall be considering only binary solutions, that is consisting of two components. Here, each component may be solid, liquid, or in gaseous state and are summarized in table 1.1, which I have provided in the next slide. Before coming to the table 1.1, see this provides this para actually provides us with the basic information which we would have learned in our earlier classes, right? Like, solutions are uniform mixtures containing two or more components, and the term homogeneous mixture means a consistent composition and property throughout the mixture. And then what is a solvent? Solvent is something which is present in the largest quantity, and solutes are other particles, other components other than the solvent dissolved in the solvent, right? And also, solvent determines the physical state in which solution exists. This is a point to be noted, because we might have not known this before. So giving it a quick glance is important, because we'll be understanding this point through the examples stated in the next table, right? Okay, so here I have given the picture of my NCRT, where I had used some tricks to remember the examples of different types of solutions, because this might also, see, as I have marked important symbol at the right left corner, this might be asked in the 1 markers again, or in a 5 mark question giving it as a subdivision, anything it may be asked, right? This is very important table that every teacher used to insist. So that is why I have given the little kind of mnemonics to remember the examples, right? So coming into the types of solutions, they have given each and every type of solution and an example for each and every type of solution with different solutes in it. So first, looking into the gaseous solutions, we have got three solutes, that is gas, three forms of solute, probably gas, liquid and solid, and the solvent will be gas. Why so? Because gaseous solutions, why should it have solvent as gas? Because this is what I told you just now. We saw that solvent determines the physical state of the solution. So whatever the solvent is, the solution also will have that particular physical state, right? So if it is a gaseous solution, then obviously its solvent should be a gas, for you to know. Then coming to the solute, so to remember the example, see, I have taken a common solvent, nitrogen. So all the three solutions, I have taken nitrogen as a common solvent, so do not have to remember the solvent anymore, right? You know that it is nitrogen now. So coming into the gas solute, you can take oxygen, because we know air is a mixture of oxygen and nitrogen gases in the air. We know that oxygen and nitrogen is present in air, so air will be the right example for a gas mixture, right? So example for it would be oxygen in nitrogen. Then coming to liquid in gas, that is liquid solute in gas solvent, remember chloroform mixed with nitrogen gas. Again, nitrogen is a solvent, so do not have to worry about remembering the solvent here. Just have to remember that chloroform is a solute here for a liquid gas solution, because chloroform is basically a liquid. So chloroform in nitrogen gas. Then coming to solid gas, camphor is a general thing we have all seen in our homes for burning the so and so reasons, right? Camphor. Okay, so remembering camphor is not a difficult task, right? So solid gas mixture will have camphor in nitrogen. So gaseous solutions, we have got three types of solute: gas, liquid and solid, and your solvent is gas, because it is gaseous solution, by the way. So your examples, if they ask, general example will be solvent, you take it as nitrogen, easy to remember. So solvent is in nitrogen. Then if it is a gas, then oxygen in nitrogen. If it is a liquid, then it is chloroform in nitrogen. And if it is a solid gas mixture they're asking for, then it is camphor in nitrogen. Over. Gaseous solutions are done. Now coming to liquid solutions, as usual, liquid solutions, then their solvent will be liquid. So we are taking the common liquid, where there we took it as nitrogen for the solvent for gaseous solutions, right? Now we are taking it as water, because water is the very general thing we know, we use, and water comes to our mind at that moment when we say liquid, right? So taking water will be useful. Then again, gas, liquid. Now we have taken gas to be oxygen itself, because oxygen dissolved in water. That is what aquatic animals use. So oxygen, again we are taking gas example to be oxygen. So gas liquid mixture will be oxygen dissolved in water. Then liquid mixture, we can take it as ethanol dissolved in water. This is also a common thing which all of us would be knowing, because ethanol can mix well with water, right? And then solid liquid mixture, again for solid liquid mixture we can take glucose, or even we can take sugar dissolved in water. That will also be easy, right? Sugar or salt, all these are solid that we are going to mix in water, right? We know these are all the simple examples we know, so taking them would be easier for us to remember, and we wouldn't have the headache of remembering such things, right? And then coming to, yes, so we are done with liquid solutions now. Now coming to solid solutions. For solid solutions, actually I couldn't find any common solid that you could take as a solvent. So I've taken the same examples that they've given in the textbook. You can use any of it if you know anything else, right? When I was studying, I just took the same examples right here. Okay, so gas solid mixture, again solid solutions, then solid would be the solvent. So um, studying about solute, first we take the gas solids mixture. Gas, we can take it as hydrogen and palladium. This hydrogen and palladium is a commonly used reagent when you study this organic chemistry. So you'll start remembering this when you study the organic chemistry part, where they'll be asking for reduction, reduction reaction and kind of stuffs, right? So you'll be remembering hydrogen and palladium. That's not a problem here. Then coming to liquid and solid, this is also kind of easy, because amalgam of mercury with sodium, and solid, which is very easy, solid mixture, because we know impure gold, impure copper, all these are solid mixtures. So copper dissolved in gold, any other metal in gold is a mixture, right? You can say any metal dissolved in gold, because we have got this impure gold and impure copper, impure silver, all these we have got mixtures in them. So remembering solid also won't be a problem. So this is all about table 1.1. With this, we have come to the end of this video. Thank you for watching. If you found this video helpful, please like and subscribe for more educational content. Don't forget to hit the notification bell so you never miss an update. Your support helps us create more valuable resources for learners like you. Keep exploring and stay curious. Bye.